Hi, everyone. And today we have Micheal with us, who has, as you can see in the background, 3D printed his own telescope. Hi, Micheal. Welcome to the channel and the stream. And can you tell us a little bit about yourself and what
All
made
right,
you
oh,
take
look.
on this crazy project?
Well, thanks for having me. Right, so normally I make film and TV props, but then one day I was I'm trying to get my young 3-year-old son interested in stuff in science. So I
Always
bought
important.
this little cardboard little telescope, this little Astromedia, I think it is. Yeah, little Astromedia Dobsonian telescope, little 70mm mirror in there.
Okay.
Built that. And then wasn't expecting too much from it. Pointed out the sky, pointed out Jupiter, and I could see the Jovian moons. I was like, "Oh, that's really cool." So then I decided that, you know what, let's just build ourselves a telescope. Not knowing too much about it, I just dove straight in. Went to
2
eBay,
feet and
found
everything,
myself a.
apparently.
Pardon?
Both feet and everything, apparently. Oh, this doesn't look that hard.
What could
Just go for
possibly
it.
go wrong?
Exactly.
Yeah. So yeah, no. So I just went onto eBay, found myself an 8-inch mirror and a 70mm secondary set together,
Yeah.
and then it just sort of snowballed from there. For lack of other words, yeah, I had to, because as soon as I made this investment in a massive, heavy piece of glass, I just couldn't, I had to follow through on it. But yeah, it was a great project. I'm glad it's over, but it was I learned a lot from it, both using 3D printing as well as carbon fiber materials, optics. Figuring out how to do the optics was an interesting one. So because sitting there with a mirror and another mirror, and then how will this work? And then getting all the distances correct and all that. It was interesting.
Yep.
It was fun. And then now I've got that. And ever since the second I put the last screw in it, I've had cloud for weeks.
That's how it works. Welcome to the hobby. So
Yes.
how long did it actually take you to like design and 3D print all that together?
Well, I believe I started somewhere in April, May, that direction. And I only finished it in the last few weeks. So it's taken me a good 7 months or so to design and build it. But that was over the course of a year, in between day job and whatnot. But it was an interesting challenge, because I designed a component, and then would that fit, and then how do I? There's an interesting progression in how I came to certain things. In my early versions, there was the spider was like a nice S curve, and eventually I walked away from that and went with laser cut stainless steel plates as vanes. Okay. So yeah, it evolved over several months.
Yeah, you had rotary vanes, then you switched to the straight vanes. I know the advantage of the round rotary vanes, but was there any particular reason you decided not to go with them?
Simplicity.
Other than the fact that they're probably a giant pain.
Now they look great, but I worried about the longevity of a very thin 3D printed component. Yeah. So I went with laser cut stainless steel, and all the fasteners on this thing are stainless steel as well, so to avoid any corrosion issues. It's built for longevity. So let's see if I can swing her around again. There we go. So yeah, it's hard to see because it's all black.
Yeah, it's okay.
But then so I had these laser cuts and folded, because I felt that it would be simpler solution and be stronger in due course. Because as much as I enjoy 3D printing, I don't necessarily want to rely on very thin components.
Yeah, and that's one takeaway with 3D printing for functional products. Not everything needs to be 3D printed in your
No.
project.
Yeah, exactly.
Yeah. I know a few
There's
people that have gone hardcore with that, and then it's like it breaks, and you're like, why would you 3D print that?
yeah. I mean, I've seen it in like in mostly cosplay stuff where someone would 3D print a sword,
Yeah.
but it'll break the minute you pick it up, and it'll swing it, or hit something, it'll just shear. Or yeah, why 3D print a tube?
Yeah. Well, it's like again, you do this as your job, so you know all about this stuff. But like if somebody wants to 3D print a sword, what I've been told is you 3D print the outside of the sword, but then you have like a piece of metal or something that you stick down the center that actually is the strength, so the rest is just nice looking on the outside.
Well, yeah, but I'm also talking like people who 3D print the handle of a hammer, which is just a long tube, and it's just why do it that way? Yeah. I have a couple of little pet peeves when it comes to that sort of stuff, like cutting an object straight through all the detail. Like, no, I can go on for days about that sort of stuff.
Days. All right, everybody, be sure to subscribe because we're going to get Michael back here to talk about all the pet peeves about 3D printing.
Well, it basically is just because you can 3D print it doesn't mean you should.
Yeah,
is essentially where I'm kind of going with that.
Obviously, you 3D printed this. Like, what did you use to like 3D print it in terms of like the printer, the materials that you use? Like, I know the outer box is actually made of wood from the photos that you sent me, but the inner telescope, like that is how much of that's like 3D printed versus, as you said, laser cut steel and stuff.
Well, the front end of it, this is carbon fiber and PETG, carbon fiber PETG, carbon fiber PETG. There's some ASA in here, more carbon fiber PETG, and then the whole mirror cell unit is carbon fiber and PETG, and the posts that hold the mirror in place are ASA. So for the most part, it's PETG carbon fiber, which was interesting. I was printing on a Anycubic Chiron because it had the massive space. And another thing was like, oh cool, I've got this massive printer. What can I do with it? I hadn't really done much with it up until this point. I made a Mandalorian helmet that I still need to finish because I hate sanding. I mean, that's the thing. If I didn't have the Anycubic Chiron, I wouldn't have begun this project because I knew I needed something big. I also knew that if I was going to be printing it and breaking it up into components, each separate piece adds another potential for failure in the system.
Yeah, failure.
Potential for misalignment.
Yeah.
So now this is 1, 2, 3 major components there, 5, 6, 7 plates. So the telescope itself isn't that many components. The fewer components you have in there, the less of a buildup of error of tolerances you get.
Yeah, that's very important, especially when error and tolerances in telescopes is very narrow margin.
But yeah, I was using it on and off, and there were some interesting challenges with that material as well, especially with the Chiron's quirks, let's say. I mean, it wasn't a hard thing to print. It was just the hardest thing was keeping an eye on things because I had a couple of spectacularly expensive failures because the material is not cheap.
No, carbon fiber is not exactly the cheapest thing, and it tends to do a pretty heavy duty on the nozzle and the hot end.
Yes,
I have to print more than you have to, right?
I printed the mirror cell went fine. I had a couple of redos on these guys at the front because what would happen is I upgraded the hot end to a volcano.
Okay.
But what would happen is as the print goes along, because of the nature of the carbon fiber material, it would sort of like fluff up and there'd be a little layer of material that just like with all these fibers sticking up. So as the nozzle would go by, it picks up material, and then there'd be a massive blob of material that would then drop off the nozzle and then sit in the path of the nozzle, which tends to end up with these. I don't know if you could see that. Nice little steps there, because this is all on the I think on the x-axis. So what would happen is that you'd get this massive blob of carbon fiber PETG, just really strong stuff, sitting in the path of the nozzle, and the nozzle would come and go. The stepper mode would skip a few and then finally work its way through and end up with a massive step in it. Yeah. But I do know that these things were very expensive to screw up.
Yeah.
Because this stuff is like £50 a spool of just over a kilo, around about a kilo. It's pretty expensive stuff.
Yeah.
And there's quite a lot in it.
Yeah.
But I didn't skimp on materials. And this stuff
Yeah.
is really, really, really tough.
You're basically printing it with 0 infill, right? Or sorry, 100% infill. 90%.
Yeah, to a degree. No, not all of it's 100% infill, but I do have a lot of perimeter lines on it.
Okay.
I'm using the old the same type of engineering involved with aircraft panels, sandwich panels. So it's a sturdy top skin, sturdy lower skin, and then a honeycomb material on the inside to sort of keep it all rigid.
Okay.
Yeah. So yeah, there's a good few perimeter lines in there. I think this one is 5 or 6 or so. Yeah, it is really, really, really tough, really sturdy.
Yeah. Like, how many nozzles did you go through trying to print that, or did you go?
Oh, what I got hardened. I had hardened steel nozzles.
Okay.
Yeah, no, I because I've printed toughened or abrasive materials previously, and I just put a hardened steel nozzle in there and let rip.
Yeah, there you go.
I think it did screw up the feeder though. I was having a look at it. There's on the grooves on the feeder spindle. It's actually like hollowed out in the middle.
Yeah,
which probably is due to all the carbon fiber gone through it.
Yeah. Add that to your consumable list on 3D printers.
Yeah, well, it's the stock. The stock feed is not fantastic anyway, so I need to replace that at some point.
Yeah.
And now is a good enough opportunity as any, I suppose.
Yeah. Finish the project, upgrade the printer, recalibrate it, and then go for the next one.
I'm not sure I'd want to print another one. It's like I'm done now with that. If I get a nice 10-inch mirror in the future, then we'll see. But again, I need to see what I can do with this to begin with, and then we'll take it from there.
Because this is obviously a very precision build. Like, optics have to be arranged properly, etc. Obviously, carbon fiber is being used because you don't want a lot of flexure in the telescope. But just out of curiosity, why did you go with carbon fiber PETG on some parts and ASA on others?
The PETG carbon fiber is mostly for the rigidity, and I use the ASA in areas where that wasn't a necessarily high requirement. I also had 2 kilos of the stuff.
No,
but it's an engineering grade material. So I would trust these materials to take them outside in the weather, well, to a degree, and trust that they don't do weird stuff like you get with PLA, which would quite happily warp and distort.
Yeah, you add some heat and it's gonna go. And again, for this thing here, longevity, nothing move.
Yes, no, I mean it's pretty, it's overbuilt to a fair degree, but it's it's not going anywhere anytime soon. I mean, if you look at this thing, there's on the secondary, there's adjustment. You can go in and out, and then there's you can rotate it, obviously, and then there's the three screws there to position it. On the other end, there's God knows how much adjustment in it, so it's all there.
Yeah.
Just don't quite know what I'm doing yet. So yeah, it's very much the deep end.
Yeah. So in terms of like overall weight, how much does it weigh? Like, is it like, I'm assuming the wooden box would probably weigh more than a 3D printed telescope almost.
Well, it's actually quite light because I used marine gaboon plywood, so it's really the wood is pretty light. There's carbon fiber tubes. So I haven't actually weighed it, but I think the glass is the heaviest part of it.
Okay.
In total. So the glass and the focus are on top.
All right, cool. So if we look at some of the pictures you have here, just because they're always interesting and fun. You did send me a picture of the moon that you took.
Yeah.
Can you give us a little bit of like inside information how you actually took that? Like, is that with like a digital SLR camera? If that's with a like
it was
eyepiece or
It was with my iPhone held up to the eyepiece while the telescope itself was resting on one of my son's chairs out in
Okay.
out in the driveway. It was not a fantastic setup, but it just to see if it worked. It
Yeah,
worked
no,
quite nicely. And I think there was
it's a
a
nice picture of the moon.
yeah, I think it's like two. I think I took the same image. I multiplied it on top of itself to get a nice bit of color depth onto it.
Yeah.
Then I think it was through a 17mm Skywatcher Plossl lens eyepiece. I'm not entirely sure.
Mhm. Well, what is the actual specs of the telescope?
Well, it's a 8-inch primary with a
Nice.
750mm focal length. It's got a 70mm secondary. So this is my first telescope. I know nothing about telescopes. I learned everything from this build. So I went and just went building this. I just decided to go the hardest route possible. The next time, I'm just going to do a cardboard tube.
We're gonna cut that part out. We're gonna cut that part out.
Obviously, with
No,
3D printed components, of course.
yeah, 3D components. Yeah, no, because
But the idea was originally that was going to be a Dobson mount, which is why you see in the base there's some M6 screw nylock screws or bolts. Sorry, nuts. I am an engineer. I'm just not very good at it at the moment. No, there's some M6 nylon nylock nuts in the base of it, which was originally going to be intended for the thing to be mounted on a Dobson mount in a box. But then I was thinking, I could. How would I do astrophotography with that if I wanted to go down that route? I mean, it would be fine for just looking at the sky and going, "Oh, that's pretty," but if I want to do some form of astrophotography, that doesn't really work as well, from what I could gather. So that's why there's now that the frame around it, the cradle, which doesn't clamp the tubes. The tubes are rested within them. So the cradle, as it were, has like semicircular cutouts that the carbon fiber tube rests in. So they're captured. It's not actually clamped. There's some room for movement. So that's So I stepped away from that, but the option is still there if I wanted to. But it's now in that mount, so I'm not going to take it apart now.
That's totally understandable. It looks amazing. And the fact that you were able to build the box to hold it and mount it to a German equatorial mount. Again, for astrophotographers who watch my channel, which is basically about astrophotography, that's why you get the phone call. If it was in a Dobsonian mount, be like, oh, that's cute, but good luck taking pictures with it.
Yeah, no. Well, that's the thing. I was because I've seen some beautiful pictures being taken of nebula and planets and stuff. Thinking, there's no way I could achieve that if it's on a Dob.
It's achievable. It's just very, very hard because you have to basically account for field rotation and a whole slew of other problems. I've seen people do it, but they're like, never again.
Yeah, no. So I was just watching videos like how to do with the Dobs, and I'm like, nah, I may as well just skip that and then build a frame for it to mount it in the onto the equatorial mount. And it's come out quite nice. And there's on the mount itself, it's made that there's 3 positions that I could put the mount the dovetail onto it, so I can swing it either side. Nice. Just in case, if I were to go and try and do that for whatever reason. Not that I need to, but it's there. It's there if I need it.
So the big question everyone's going to ask in the comments, if they ask anything, is where can they get the are you going to make the files for like the design files and stuff public potentially? At one point, free or paid or?
I haven't really put that much thought into it, to be honest. I need to sort of collate all the versions of the files together, all the latest versions of all of them. But it's really catered specifically for a specific mirror setup. So it's designed around that 750 mil to a 203 mil diameter mirror and the 70 mil. So you'd need to get the exact same glass to go with it.
Yeah,
which isn't, I mean, I can add a link to that, but it's don't think that you can then go, oh, I'll happily put in a larger focal length on there, but because it's not designed for that. But yeah, no, I'm quite happily
one type of mirror, one type of secondary that you'd need in order to make this work. Otherwise, the math is off.
Yeah. I mean, it is, as it is modular. So in theory, if I wanted to put a longer focal length in there, all I'd need to do in theory is modify the plate that the ring that the mirrorcell sits in.
Mirrorcell, yeah.
Because the carbon fiber tubes run from the front to here, but I'd need the distances where it would mount would change. So this plate would need to be altered to put a longer focal length in there.
So did you actually 3D print the carbon fiber tubes, or did you buy those?
Oh God, no, those are bought. No, those are twill weave wrapped tubes. So there's some decent strength to those. I mean, it's even without the cradle around it, it's they're strong enough to keep everything nice and straight. But now with the cradle, it's even more supported. So there's going to be even less flex in the system, because you're going from having to support it. Hang on. Having to support it just at this base point to here, to having those shorter distances. So all they're really doing now is just keeping the distance between the two. So it's over engineered, but it's good and stiff. And I also made a jig for these tubes as well, because the end caps are at 60 degrees offset of each other, and they're handed, so there's a left and right hand one. So I printed a jig that I mounted them all in I epoxied them, slid them into the tube, and then bolted them to the jig until they were ready, until they were cured. So I knew that those are all identical as well.
That's good.
And all the same length and the same. So I try to eliminate as much error there as well by doing it like that.
If we talk about the mirrorcell here, it looks, I'm blanking on the terminology, but looks like you have a 9-point mirrorcell.
Yeah.
And did you have any trouble making that yourself? Like in terms of like any tips anybody wants to try to 3D print a mirrorcell should know?
Well, let me swing it around so you can see the back of it. There we are. You see that? Was this just a black hole?
There's some light. Yep, that's better.
There it is.
We're good with that one.
So yeah, it's a 9-point mirrorcell. Obviously, the more points, the better. But I thought 9 was would be enough. I measured out all the components for it, so I got a bag of basically the pads are mounted on brass dome nuts. So I measured all the heights of those. I measured all the heights of the washers that go between those and the dome nuts and the frame. So I got them all within a very close tolerance to each other. Then I laser cut some pads to go between these little, what would you call these? There's
the tables.
Tables. Yeah. So there's all POM pads on the tables that then screw into the carbon fiber PETG stuff there. So yeah, basically all I did was make sure that everything was in a very close tolerance in height to each other, so there'd be minimal movement. to keep it all as level as possible.
Yeah. Oh, what are you when you said the pads, what are the pads actually made out of that are
POM,
actually touching?
POM, 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 polyoxymethylene,
Okay, there you
POM.
go.
Yeah. So it's a engineering plastic,
Yeah.
which has a very low friction to it.
Yeah.
So the whole mirror can, I mean, I can move it around as it is now. It's very loose. The cell is designed in such a way that there's two posts at 45-degree offset from center, that the mirror rests on that.
Yeah.
So it's not held firm. So it's got space to move around.
That's good. And like, how did you determine where to put the points on the telescope? Like, did you use software to do that, or did you?
There was I can't remember off the top of my head, but it was there's a website that you can do the size of the mirror and then how many points you want to support it with, and then it worked out all the diameters for all those stuff for me.
Oh, that's good.
So it worked out where these points needed to be and then where those points needed to be.
I know you said you haven't had a huge amount of time to use it yet, but like it's a very open concept. So there's a lot. Are you concerned about like stray light coming in, hitting the mirror, stuff like that? Do you have any plans on how to sort of solve that? In terms of like a shroud or something?
Oh yeah. Well, I've taken over my girlfriend's sewing room for this chat. But what I'll probably do is approach her to create shrouds for me, elasticated material that would then go around it like a sock, basically.
Yeah.
To keep stray light out, maybe like black velvet or something.
Yeah. Yeah. No, because I was looking at going like it's the mirror's open to everything now that you moved it, and I realized, oh yeah, there's nothing protecting the back of that, because like for dust and whatever else coming down. So dew is definitely a thing. Do you have like dew heaters set up for it, anything like that, or is it sort of?
Honestly, I only sort of started worrying about or learning about issues with dew after I built it. Like, how am I going to solve that?
This is new information I'm giving you that you're like, oh.
Well, not quite. I mean, again, bear in mind, this is my first actual real telescope, aside from, the cardboard one.
The cardboard one.
But yeah, that is definitely something I need to bear in mind. I've got some fans to sit on the back at some point that would then, help cool the mirror, but also create airflow that will then hopefully deter stuff from landing on it.
So here's the thing.
I don't know.
Yeah. So here's the thing. So the fans are used at the start of the night to cool the air down to the temperature that is surrounding it, so it doesn't flex as you're imaging. But once you reach temperature, you actually turn the fans off, because any air movement causes can't remember the word, but it'll cause the image to shift ever so slightly.
Yeah. The old twinkling of lights and stars. It's the same thing. It's changing air density.
It's just inside your telescope, very bad. I think it's called column effects, and it ends up causing some weirdness to happen. I don't remember what the exact term is. We'll call it aberration, but there's a specific term.
See, that's new. I had no idea about that.
That's why I was asking. Like, are you planning to cover the outside of it in any way to stop the stray light, the dust, any wind from going through it? Small baby fingers reaching in and going, let me touch it.
Yeah. Well, to be fair, my 3-year-old's been pretty good about that. But yeah, he's because he's taken an interest. Every now and again, we'll look at the sky and look at the stars, and I'll take the little cardboard one. So I got the cardboard one, so he can look at the sky, and will not be too upset if he accidentally steps on it or something. As 3-year-olds I want to do. But yeah, he's been pretty good about it. But yeah, I do need to address that at some point. I have thought about that.
Yeah.
But yeah, as I said, it'll probably be a sort of a sleeve that'll go over it, definitely around the top, around the front, and then probably around the bottom as well, and have it hook around here with Velcro around the frame, and then hook around here, maybe with custom 3D printed components.
Gotta
a bit
3D
of
print the whole thing. Just 3D print a tube. You know you want to do it.
yeah. No, next time it will be. I'll 3D print the mirror cell and the components for the secondary, but the frame, the body itself will probably be a prefab tube of some sorts.
Yes. Oh, definitely. So going forward, is there anything like, I know you've just got it, it's just finished, you're going to be using it. You definitely should be thinking about putting a shroud on it. But is there anything else that you can see right now when you're looking at saying it's working, it's great, but I would want to improve it by doing something else? Like in terms of like, do you have any plans to upgrade it over time, or is it like this is it, it's done, and it is what it is?
This is my first foray into telescopes, so I'm going to see what this does. I mean, I haven't actually been able to use it yet, not in the state that it is now.
Yeah.
I mean, the few photographs I've taken through it were when it was leaning on a box or on a chair. So it's not ideal circumstances. Now it's in a mount. It's it's ready to go, but I haven't had the opportunity to do so. So once I've been able to give it a good road test, as it were, then I will be able to take it from there. There are certain things I probably would do differently next time, such as there's 2 vanes. So there's 6 vanes. I probably could go down to 3. There's a lot of material in places that I probably could have done without. So I could have just slimmed it down in places. Yeah, so I don't know. I have to see what it does first, and then take it from there.
So just to wrap up, if people want to follow your journey with this 3D telescope or 3D printed telescope and find out how it goes, and sort of maybe see some of your astrophotography once you get going, is there like a social media handle that you use or something, or like follow you on Twitter, Instagram, something like that you might post the pictures?
I'll probably be on Instagram. Twitter me is very angry me, so try to just crowbar myself away from that. But yeah, it would be Instagram probably where I want to put all the pictures of stuff I photograph, as well as robot toys and stuff like that.
Yeah, no, I'm very impressed with this, and I think we're all looking forward to seeing how this turns out. So be sure to head over to Instagram if you have it. And thank you very much, Micheal, for taking the time to talk to us today. Thank you for sending the photos and giving us all this insight on how to do it. Again, I am so pleased to hear that somebody's decided to 3D print this. I'm just shocked to hear this is your first telescope. It's just like there's the jump in the I'm still just like that I jumped in with 2 feet. It's like, sir, you jumped in with 2 feet, you pushed your firstborn in there with you, and you said to the in-laws, come on everybody, the water's fine.
You have your way, and it's making me weaken. You and your status, walking like that. It's really getting too much, but I can't pull back. Though I try to resist, I can't fight this. And no one makes me feel like you do, and no one sets my body on fire, and no one gives me shivers like you. Oh, no one does it better. How I try to sleep, but you're deep in my mind. Got a hold of me. When I'm awake, I'm all blind. You and your magic, like infinite power. God knows I tried to resist, but you're pulling me closer. Oh, I gotta stay away, but you won't let me